Tried recording and stuff, but the audio didn't work, so I'm just gonna go right back over it. Basically, feedback is an important idea in delays, and this is a bad implementation of it for lots of reasons, but mostly because it has these two loops. And it looks a lot like our old ones, which is nice, but it's not what we want to be doing. We want to be doing something called a circular buffer delay. Circular buffers are just a way of storing signals in paths that we can then overwrite when we don't need them anymore. This is all the same. I'm just going to set the length of the buffer here, and we're going to make this buffer. Don't be worried about the fact that it says np.zeros. This just makes an empty buffer with 0 as every sample with this length. It's actually an array, but it's the same as a buffer. So then we have this idea of a write and a read pointer, and they're just both going to be these things that show us where we are writing and reading in our circular buffer. And so we'll see why that's important in a moment. So here we're just going to loop through our samples. We'll start at sample 0, and we'll just look at circbuff write. So we'll notice that circbuff write is in the middle of circbuff because circbuff is n times 2 long, and n plus 1 is in the middle of that. And we'll notice that read is, of course, going to be back in the buffer. So we can imagine read being here, and then a bunch of stuff in between, and then write, and then a bunch of stuff after. So then we're going to assign to this write just what we have here. So this is just the sample plus the feedback times the sample we're reading from. So essentially, this is a circbuff read represents our delayed sample. Circbuff write is the sample we're about to set. So circbuff write is just going to be in front of circbuff read in this buffer, and we're going to just get the read value back here when we want the delayed sample. So this is just saying feedback times the delayed sample plus sample, and we're going to write that to circbuff write. So then we're going to just append to our output circbuff read times mix. So this is what we saw before. Circbuff read is the sample that's delayed, and sample is the sample that's just happening. So this is the same thing that we had above. So the question is, like, why is it a circular buffer? It seems like just a buffer. Well, something is going to happen eventually. We're going to get write up here. Read is going to follow, and eventually write is going to be at the end of the buffer. And so what we're going to do is that after the loop through each sample, we're going to add 1 to write and add 1 to read. So they're just going to go forward 1. So each time they're going to go forward, and then it becomes circular because we are going to wrap write around. So when write hits here, and we add 1, it's going to be, so when write's going to be n times 2 plus 1. So it's going to be out here. Actually, I mean, it's index value and n times 2. But anyway, it's going to end up over here, and then we're going to have to put it back at the beginning. So it's just going to keep going around and around, and so is read. And so that's just what this does. A mod b takes the remainder of a divided by b, and so write mod equals buff length, we'll remember, is equal to write equals write mod buff length. Those are the same, these two. And we're going to do the same thing for read. So this is basically just saying if read is longer than the length of the buffer, we'll bring it back to the beginning. So you can see how this structure that goes back on itself circularly is what a delay is in practice. And this is going to be our much better way of implementing delay because, for one thing, it's more intuitive based on how we think of delays in practice and in the analog world. And for another, we don't need this inner loop. So we, instead of having a ton of processing time spent working through this loop, we're just going through each sample just like we were above. So this is both cleaner and I think simpler to understand, but again, it's complicated the first couple times. So If you have problems with circular buffers, you can Google it. There's information on it around, and you can ask me. Either way, no worries. We can load an audio file like this and run a process on it. In this case, this is our file right here. Or I'm sorry, this is our function right here with the arguments 0.2 seconds delay at the sampling rate with 0.5 mix and 0.9 feedback. And then we'll just write that to an output, and it will work. I can't show it to you here, but you can feel free to download this code, and it should work. Note that if you've downloaded it already, I had an error. This used to say write. It's wrong. It should be read. That's just my bad. Anyway, thanks so much for listening.